Because what we're going to do is we're going to look for electron configuration, but we're going to use the periodic table to do it. In your very important paper section of your OneNote, you have this periodic table. It's the third thing down. It goes expectations, then the regular periodic table, which we've used a lot. This one I've changed, I use because it's slightly different. In the one above, you'll notice that these guys, lanthanum and actinium, are actually up here, whereas down here they're down on the bottom. And it does make a difference when we're counting electrons and where they are. So that's why when you get the test, you'll get the regular one on one side, you'll get this on the other side of your periodic table rather than just the yellow one. So we're going to be looking at this and just looking at basically how it's set up, how you can use this to help you figure out the electron configurations. So this whole side here are the S block, your first two columns. Alkaline, your alkaline earth metals. Over here is your P block. Okay, this is your D block down here, and there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 of them, which makes sense. We said that there are 5 shapes that can hold 10 electrons. Down here's your F block, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So that is 14 blocks, which is good because we say F block is 7 shapes, 2 in each one, gives you 14 electrons. And you can see they already numbered these for you. P1 through 6, S1, S2. Helium here is a little weird. He's so small, he could only have 2 electrons, even though he is a noble gas. That's why it's kind of floating over there. But he doesn't really go into the P blocks. He only has 2 electrons, so he's not going to. So he's there. He's just floating. So that's kind of how this is laid out. And let me show you how you can make that useful to you. Let's say we were going to do lithium. Now, when you're using this, you always start at the beginning. The "you are here" sticker goes right there. 1, 2, 3, 4, 5, 6, 7. Those are your principal quantum numbers, or the capital or the big numbers when you're writing your electron configuration. So we're going to need those. They're just the rows. You can count to 7. It's not something you really have to memorize. You just have to count. So if we're going to lithium, we're going to start at this. We're going to go through 1s1. So we write what we go through. Oh, we don't write 1s1 though, because we're going to fill it up. 1s1, 1s2. So that's full. I'll write it. Now I'm going into my second energy level. I'm in the S block. I'm in the first one. So lithium's electron configuration is 1s2, 2s1. That's it. And you can check to make sure you're right by adding these superscripts. 2 plus 1 is 3. And lithium is number 3. Okay, those should add up to your number of electrons. Let's try another one. Let's try oxygen. Okay, we're still starting over here with 1s1, 1s2. 2s1, 2s2. Now we're still in 2, still the second row. 2p, 1, 2, 3, 4. So 2p, I went over 4 spots. So my option is 1s2, 2s2, 2p4. I'm going to double check. I have 4 plus 2 is 6, plus 2 more is 8. Oxygen is number 8. So oxygen is 1s2, 2s2, 2p4. So the first energy level, rotating in a sphere, we have 2 electrons. Second energy level, rotating in a sphere, is 2 electrons. And in the p's, we have 4 of them that are orbiting in those p orbitals, or the dumbbell-shaped orbitals. All right, let's try another one. Let's try aluminum. Picking randomly here. All right, 1s1, 1s2. Second energy level, in the sphere, we went 2 spots. Second energy level, in the p's, 1, 2, 3, 4, 5, 6 blocks. Third energy level, in the s's, 2 blocks. Third energy level in the p's, just the 1 block. So 1s2, 2s2, 2p6, 3s2, 3p1 is your electron configuration for aluminum. All right, let's try another one. If you think you're getting this, pause it and try it on your own. We're going to do potassium next, which is number 19K. So pause it, see if you can do it, and come back and make sure you're right. All right, so we're going to start right up here. 1s1, 1s2. Second energy level in the sphere, we go 2 spots. Still the second row or second energy level. Now we're in the P block. 1, 2, 3, 4, 5, 6. Third energy level, we're in the S block. We go 1, 2 spots. Still third energy level, we're now in the P block. 1, 2, 3, 4, 5, 6. Fourth energy level, we're in the S block. 1. 1s2, 2s2, 2p6, 3s2, 3p6, 4s1. All right, so that's the general gist. Now remember I said when we got to calcium we didn't have to do those drawings anymore? We still do electron configurations, just no drawings. So to show you how to do that, I want to tell you about this little roadblock we got. So when we hit that P block, you see how there's this darker line here? There's a meaning to that. Okay, there's another one over here. It's kind of like a speed bump when you're going on this road. When you hit that, this is 1s, 2s, 3s, oops, sorry, that's going to write 3s again. That's impossible. 4s, 5s, 6s, 7s, right? And we said this is 2p, 3p, 4p, 5p, 6p. You don't have to rewrite this. They have pictures like this on the internet. Just Google it and put it in right next to this or right underneath this. All right, so those are your p's and your s's. Now, when you get to this little roadblock here, when you get to the d's, because the d's take so much energy to go in that shape, the 4 lobes, it actually goes down in energy level. So this is 3d, not 4d. This one's the 4d, 5d, 6d. Okay? That's because it takes more energy to go in a 4 lobe than it does to a sphere. So it's going to fill the spheres before it fills the 4 lobes. Okay, the other roadblock, when you get here, notice it goes 56. Well, 57 is down here. So 6s2, we're going to go into 4f14. 5d10, 6p6, 7s2. Now remember, after 7s2, we have to go down here, and that's the 5f's. You subtract 2 when you hit this one. The reason is because it takes a whole lot of energy to those f blocks. And every time you hit here, you add 1. Okay, and that's the principal energy level, or the 1 through 7 that you wrote, the big number. So let's try one. It's all the roadblocks. It's everything you need to know for this whole thing. Okay, here we go. Let's try iodine. Okay, it's 53 electrons we have to account for. Still start up here because they're in the ground state, so we have to account for all of them to prove that they're in the ground state. First energy level, 1s1, 1s2. Second energy level, sphere, 2. Second energy level, P block, 1, 2, 3, 4, 5, 6. Third energy level, spheres, 2. Third energy level, P's, 1, 2, 3, 4, 5, 6. Fourth energy level, spheres, 2. Now this is the roadblock, remember. 3D, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, and then 4P, 1, 2, 3, 4, 5, 6. Fifth energy level, S, 2's, 4D, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then 5P, 1, 2, 3, 4, 5. So iodine is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, 5s2, 4d10, 5p5. Okay? Let's try another one. We'll do 2 more. Alright, so we're going to do another one, but we're going to want to use the F block in there too, so we get a really good idea of what's going on. So let's do uranium. It's down here somewhere, 92. It's a lot of electrons. We still start up here. 1s2, 2s2, 2p6, I'm just going to cross all the way through, 3s2, 3p6, 4s2. Now we got to the D's, 3d10, 4p6, 5s2, 4d10, 5p6, 6 energy level, 6s2. Remember, we have to go down here. 4f14, and everybody forgets those f's. Don't forget your f's. 5d10, 6p6, 7s2, and then 5f1, 2, 3, 4. So uranium's is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, 5s2, 4d10, 5p6, 6s2, 4f14, 5d10, 6p6, 7s2, 5f4. All right, the last one we're going to do, and you can try this one on your own if you've got it, is the very, very last one on the table, which is 118. It's not even on this table because it's so old. But it's been discovered. So we're going right here. Octium, I believe. All right, so you can do that one. You can do anything on the periodic table. Remember, we have 1 through 7. Okay. Start up here with 1. 1s2. Yeah, leave room. 2s2. Sorry, I'll cross them out. 2p6. 3s2. If you know how to do this, you should have paused and you're just checking the answer. 3p6, 4s2, 3d10, 4p6, 5s2, 4d10, 5p6, 6s2. Careful, don't forget your F block. 4f14, 5d10, 6p6, 7s2, 5f14, don't forget them, 6d10, 7p6. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, 5s2, 4d10, 5p6, 6s2, 4f14, 5d10, 6p6, 7s2, 5f14, 6d10, 7p6. That's the longest one you're ever going to have to do. If you can do that one, you can do anything on the periodic table.